Okay, so awesome. I think it's live.
I see it. It
Awesome.
is live.
So
Yeah. Yeah. Yeah.
awesome. So I think we can start. Okay. Okay. Um, awesome. I think we have a lot of people joining. Thank you everyone for joining us today. And I'm going to share my screen and we can start. Over to you, Alessandro.
Yes. Thank you, Nancy, and welcome everybody to the second edition of the CNCF Cloud Native Sustainability Week. It's a great honor and pleasure to be part of this team and to be able to present to you the state of the art of research in cloud native sustainability. We have a interesting program, last minute cancellations, but we made it up. So there is enough people that they want to share their stories about cloud native sustainability. For me, it is the most important topic today. Our arts and prayers, if you are into that, goes to the people in America that they are experiencing heavy weather now. You may have different opinion, but I think this is also part of the climate change, and so I think it's important that we all do our part for addressing the most important, the most pressing challenge of mankind at this point in time. So we are here to discuss what can we do together to make our software more sustainable, to reduce the impact on our environment, and to, in general, make do what we can with what we have to work on. Right? We all have our part to play. Cloud providers, software engineers, architects, platform engineers. We all work with these tools, so we need to work together to leave a better place, a better planet to our kids. So that said, we have a pretty tight program. We have many speakers, as I said. So this is the Cloud Native Sustainability Week. This was born, is an idea was born pretty much when the tag was formed. Leo can give some context. I wasn't around at that time, but it's a global event, right? So we encourage and support local meetups, in-person meetups, to get together, local communities get together and discuss this topic in this week, so they can spring the discussion in their local communities about this topic. So I don't know the counts of local meetups as of now, maybe 19, maybe more. I'm not so sure.
Yeah, we have like over 20 plus
20 plus.
20 20 plus countries and like meetups happening across different countries. So that's an amazing number.
Yeah.
Yeah, yeah.
And
So
we are working. Yeah.
and we're working on it more. So
Yeah.
maybe yeah, maybe I can like tell a little bit more about Cloud Native Sustainability Week. So we did it like it started last year, and we had like a lot of local meetups, online meetups, mini conference, blog post. So the whole idea is, as Alessandro mentioned, the whole idea is that we come together, we discuss about this topic, and we are able to learn things and adopt and adapt these practices and adapt these things are in our engineering team. So we as software engineers and engineers, we can play our part in making sustainable software. So that's the whole agenda for Cloud Native Sustainability Week, and one of the main goal of the tag. So yeah, we have local meetups, we have online meetups, we have live streams, and one of that is today, like the virtual mini conference. And we have multiple blog posts which talks about different things, which can be really helpful for the sustainability, for adopting sustainability in your teams. Um, awesome. So we have a technically advisory group for environment sustainability. We are part of that group. So it supports CNCF community and open source projects to become more sustainable. You can read more about it at tagenvironmentsustainability.cncf.io. We generally have weekly meetings. We have two groups which Nikki, Claire, Valeria are going to talk more about later. So we have different working groups with different goals. And if you want to contribute, so you can join it. So yeah, this is what I've talked about. We have working group communications and green reviews. So working group communications is more about sustainability advocacy, talking about sustainability, different blogs. If you have something to share with the world, you can come and tell us, and we will be happy to post it. And there are different events which is happening now. Cloud Native Sustainability Week, it's a part of it. So that all comes into working group communications. Then we have green reviews. It has activities related to measuring the sustainability footprints of all the CNCA projects. So super excited for this. We're going to talk more about it in detail later today. And will you, like, Alessandro, over to you.
Yes.
Will
So thank you, Nancy. Um, this is one of the most active tag, really. The meetings are happening every week, and it's we have different topics to talk about. One that is picking up, of course, is AI sustainability, where we discuss the impact of especially cloud native AI as on sustainability. So, and we always welcome new joiners, and we need you, and we need everybody to join and discuss. And even if you have different opinions, I mean, we value diversity not only in gender or whatever, but also in opinions. And we are open to accept and welcome everybody that wants to do their part. So we meet every Tuesday. I think every other Tuesday there is the general, and then there are specialized working groups meetings, of course, that you can join. There is a please go to the Tag Environment Sustainability website, and there is everything there. There's a calendar. You can see what's going on. So that's it. Yeah. Leo share the we can share it also on YouTube. This is how you contribute. It's really not magic, and it just show up. Showing up is contributing. Showing up means literally just be there at the right time and the right place, which is mostly Zoom, uh, and be there, right? So, and open your mic, or even better, open your camera, but then just contribute with your contribution, with your own individual personality and background to our activities, and it just takes that. We do have, of course, a GitHub repository with full of issues. We do look at those from time to time to know what to attack first. What's the most pressing order of things to do first? But mostly is getting together. For sure, if you are in Salt Lake City in a few weeks, we're also gonna have a booth there, and you are very welcome to join and have discussion at the booth. Even better, I don't know if somebody started yet, but usually we also have a agenda of people that man the booth. Should be, and they are there to help and to explain what the tag does. I did it last year, it was great because you get to talk to real people that want to know more about the activities of the tag. So I don't know if anybody start probably after this week, because we've been very very busy. We'll start preparing for KubeCon.
you? Yeah. I
Yeah.
just wanted to add up to this, like as you mentioned that it's kind of easy. I mean, definitely it's about showing up. So there's a CNCF Slack which is tagging environment sustainability, and like one of the first step is, I think if you're joining us today, you're already part of it. So if you have any feedback or if you have any question, you feel free to join the Slack and you can tell us. There are usually the weekly meetings which happen. There are different groups which Nikki and Valeria and Claire will cover it up. And according to your interest, you can join that. So yeah, that is how you can contribute. So yeah, today you're going to meet Alessandro. We have Sayam, Leo, Claire, Valeria, Nikki, who will be telling us more about the tag. How can you join? How can you contribute? And yes, Alessandro, would you like to talk, walk through the speakers?
Yes, of course. And thank you everybody to submit the talks. We have more talks submitted than we could select. But I hope you enjoy the great lineup. I was thinking while selecting the talks, I think we have enough to do it almost every month. And yes, it's a lot of efforts, but there is a lot of willingness in the community to share the story. So yeah, if you didn't get accepted this time, keep submitting. We might think of doing this on a regular basis, maybe turning it into a webinar series. And you can always join the community calls and come and share your story, and we'll find the right space for you to talk. So we have two main talks, so from Aisha and David. And then we have three lighting talks from Vilko, David, and Shivai with Rohit. And then, of course, we're going to close with Brendan Bars as a keynote to global in sustainability. Without further ado, we are a bit short on time. Next is Leo and Sayam, if they want to introduce the tag, because you guys are the chairs, right? So I'm pretty sure Leo and Sayam are the chairs. Correct me if I'm wrong.
Yeah, that's true.
Yeah.
We
So
have Leo and Sayam as the chair. Sayam is, and Leo has been there with the tag since the beginning. So I'm really excited to hear about the story of tag as well from you, Leo. So would you like to share the
you
screen?
guys take it away if they are online, of course.
Hello, yes.
Yeah. Yes.
I believe Siam will share his screen.
Yep, I'm doing that. I'm also switching my camera to the other one. Yeah.
To the
So
good one.
yeah, to the good one. Screen two.
All right. Yeah, also hello from my side. Very good to be back. This event, yeah, as Nancy and Alessandro already mentioned, we organized this last year for the first time, out of the blue. So this was like an idea that we had like 2 years ago, and then we just gave it a go. And we had last year also over 20 meetups, daily blog posts, and so on. And this year we are back, and I think this is great. Yeah. So I think, Siam, we will go a bit over the website,
Yep.
just to show like the perspective if you are interested in contributing, how it looks like, how you can navigate things. And if you have like any questions, we can talk about a bunch of stuff. The field is so like large. And yeah, feel free to ask questions also.
Cool. So yeah, my name is Sam Bartak, and I'm currently the tag lead. Also, as Nancy mentioned, there is, apart from the regular sustainability meetings, we do have the APAC time zone friendly meetings as well. So make sure you are checking the calendar and you are um, on time for all the stuffs. And this is the events. There's the GitHub repository for the tag environment sustainability, where you'll be able to find interesting issues and all the stuff which is there, especially the working groups. And then for each of the working groups, you'll be able to find, obviously, we have more deep dives into the green reviews and the communication working groups, which they'll highlight more. But yeah, you can read more about each of the working groups and some of the things as well. Just to so tag sustainability from the CNCF point of view is definitely very important and critical. So as software developers, I think we connect more when we can do something within the software ecosystem with our code, with the stuff that we do, with the Kubernetes layer on top of the infrastructure, and not leaving everything to the cloud for the sustainability efforts. So the main thing is the carbon emissions, and we cannot leave everything to the cloud provider. So cloud providers, yes, they do provide certain metrics. Some do, some do not. Some are still working in progress to provide those metrics. But yeah, the sustainability with respect to cloud native, um, is you have that infra layer. Then mainly you have the Kubernetes layer on top of that, and you have various tools, applications, and your applications which are installed on that. Now, the stuff that you create and the stuff that you install and the resources that you consume also gets mapped, because they are abstracted from direct one-to-one mapping. But in the end, you can map, and there are tools. So you definitely can map those and try to get the metrics, the carbon emission metrics for that. And you can then try to effectively use those, how to efficiently use the resources that you're using. Because in Kubernetes, you do kubectl get nodes, you get the nodes. Those nodes are actually running on a particular piece of hardware. That hardware is consuming electricity, and everything is can be mapped, and there are various tools for that. Leo, would you like to add anything for this?
Yeah, so I think so if you buy any products, you have like something physical like in your hand, you have like a feeling for the product. And with software, this is obviously not the case. So everything is abstracted away, which makes it a lot more difficult to get a feeling for the resources that you use. So if you have like fancy, I don't know, like AI algorithms right now, which are coming up and in the maturity curve are not there yet in terms of optimization and reducing the energy impact. It's more about like opening new business values and new business fields and sort of like sort of striking like a new top of technology. And that's awesome and everything is good. And however, it's also important to keep and be aware of the resources that we consume on the way. And with software, as I said, it's easy to forget about this part. So at the end, it comes down to the sort of the engineers that using the cloud providers. So the cloud providers cannot really tell you usually how you use your business applications is effective for your business case. This is something that you need to evaluate for yourself. But if the cloud providers cannot evaluate the effectiveness and you have to do it yourself, you also need to be aware, at least with some metrics, about the resources that you use. And I mean, we are like, so when we talk about energy consumption, the energy infrastructure, especially like in Europe and also in other areas, is changing. So we have more dynamic patterns in terms of energy production and also consumption. And software is a field where you can shut down software, you can build software to react to these variables as well. So the goal is that we build cloud systems that are typically big, right? Kubernetes was built to power big systems. So we have naturally a sort of like a larger footprint with resources and energy that we understand, okay, there's new requirements coming in, new quality requirements, that we care about the resources, that we have like a feeling for the resources, that we transport this information upwards. So the platform engineers and at the end also the application engineers can do something about it. So that's basically sort of like the way we're going in the CNCF. We focus on the cluster side. we need to somehow connect the abstraction layers again, which we separated, right? And yeah, understanding the invisibility factor of software. So it's not like necessarily like a new topic. Lean software and so on. It's like something that is discussed for, I don't know, 30 years plus or even longer, right? So, but it's still a topic today, and with that we are more aware of the resources that we use and consume. It's a topic for the cloud.
Yeah, and you can watch the space, watch the tag for the activities that they are doing, especially for the green reviews. Very interesting working group. And I don't want to like tell anything. I leave it to the chairs of the working group to tell more about that. But yeah, you can also come to the landscape and see which all areas, for example, infra tooling, observability, data centers, methodologies, and then for each of them, what all tooling is available, and then you can go to that tooling and see how it can help you in optimizing or help you getting those CO2 metrics, or whatever it is, since it's in the landscape, so it's related to the sustainability thing. So you can see how you can try to implement that in your particular project. And there are for the infra, for the methodology, scaling, CADA, you might be knowing that, and a lot more. So a lot of sustainability initiatives are there, and then this particular thing, which Nancy and Alessandro are hosting, the Sustainability Week, is happening all across the globe, with kind of a single goal to educate and educate people more and more about the software sustainability, how it works, what are some of the existing tooling, what are the existing practices, how some of the people or the organizations have already implemented this or are doing this, and some of the toolings that people can use within their ecosystem. Anything else, Leo, you want to add in general about the tag?
No, not really. I mean, at the end, it's a community project. It's powered by community folks. So these events like this one is very important to also get feedback, even if it's just attending a meeting, dropping one thing to the agenda, or opening your mic at one of our meetings just to share your ideas, opening up an issue, something like this helps us. Yeah. Thanks, everybody.
Thank you.
Thank you, Sayam. Thank you. Thank you, Leo. We are short on time, so that's why I'm sorry to push a little. But if Aisha, if I pronounce it correctly, is ready.
Hello.
Hey, hi.
Yes.
And thank you for accepting the slot. I know it's late, but we met just a few weeks ago, and I thought your talk was great was perfect for this audience. So if you can take it away, and good luck.
Well, thank you. For me, it was a challenging to go from a 10-minute talk to 25-minute talk. So let's try it. I'll try not to bother you with much details. And let me share my screen. Okay, so let me just everything screen. So hello everyone, and I could say welcome to the fun part or the fun side of software development. Today we will explore how to build eco-friendly Java apps that run smoothly in Kubernetes. But before we start, let me introduce myself. My name is Aisha Latia. I am a Java software engineering with a love for coding, a heart for volunteering, and the taste for delicious food. I'm also part of many local international communities, such as a Women Tech Makers in Girls Code Ambassador, member of Moroccan Association for Computer Science. I used to be a community leader for Peace Tech Morocco. And right now I'm trying to contribute as much as I could for everything related to the backend development, for encouraging women to be more here, more present in the tech industry. And also, fun facts about me. My weekends are always reserved for two things. It's either museums or Formula One. And now the most important question you might ask. Why am I doing this talk? Well, did you know that the tech industry consumes approximately to 7% of the global electricity? Data centers alone contribute to 2% of the global greenhouse gas emission. And they say that by 2030, it will be 13%. Inefficient software contribute to that. But as a developer, we have the power to change this. By coding like a 3D brute with efficient brushes, we can reduce waste and cut down our environmental impacts. Now, if you still think that the 2% is a small amount, here is a fun fact, or I should say, not fun fact. The energy consumed by data centers alone is equivalent to the entire airline industry energy consumption. Imagine if we could reduce that by just optimizing our code or making some smarter, greener cloud choices. And now, it's your turn. What's the first thing that's come in your mind when you hear, for example, like green programming? Do you think about energy, recycling, something else? Don't be shy. Try to type what you're thinking in the comments. I'll read it later. But if you think about something related to sustainable energy, something about optimization, you're all right. Because green programming involves developing softwares with the focus on energy, efficiency, and sustainability. It means writing code that use less power, optimizing our applications to run more smoothly and more efficiently, and of course, considering the environmental impact of our software. And now let's explore some strategies for green Java development. Like these techniques can help optimize resource usage, reduce energy consumption, and of course, always lowering the environmental impact of our software. Starting with optimizing Java for efficiency. First thing we need to know is why efficient algorithms are matter. Because choosing the right algorithm can drastically improve performance and reduce energy usage. For example, let's imagine that we can say that we are sorting 1 million items. If you use, for example, bubble sort, it's like choosing to count each grain of rice in a set. Painful and the time consuming. It might take to almost 1 trillion operations for only to sort one item or to select one specific item. Now, if we switch to some efficient algorithm like quick sort, suddenly it's like someone hands you a super efficient sorting machine. We're down to just 20 million operations. It's just 90.1998% reduction in efforts. Imagine your process is like breathing in a sight of relief. And here is our friend Leonardo cheering for this epic win because choosing the right algorithm saves time, energy, and maybe even a few headaches because, efficient algorithm is your ticket for a greener, faster, and happier software, which is, as a developer, will be happier too. Moving on to the second thing, which is memory management. Like memory management can help you ensuring that you have like smooth performance while reducing energy usage. So first thing first, or first really need to make in your mind is that reuse your objects. Why create more mess for the garbage collection when you can reuse what you already have? Like you can less clutter means fewer dizzy pauses, and that's a win for both performance and energy. And that's a big win for sustainability also. And when it's come to the garbage collection, Java gives you options like a buffet, but not all the choices are the same. For example, we have the G1 GC, which is like your balanced meal, because it works well with most of application with a good mix of everything. There is Shinandwa, my favorite one. It's for who's with the big appetite, like big hips who want some low poses times, but also because Shinandwa doesn't care about how what about the size of your hips. Whatever it's big or it's small, it's always guaranteed that you will get low POSIX times. And there is the ZGC, which is the Super Premium Ultra Ultimate Low Latency Choices. It's one of like the really garbage collector that the community is working on it on their newest feature. It's great when you need to keep everything smooth, even for very large applications. And of course, there is Epsilon. That we can call it the no GC option. It's like choosing not to clean at all. It's great, like for example, if you want to test or for super short runs, but please do not use it for production unless you want your application to crash. And now moving to the GVM. Like for example, because proper GVM tuning tips such as like proper tuning because it's allow you to allocate memory for more efficiently, ultimately improving performance. And one of the two crucial settings are -XMS and -XMX, which set the initial and the maximum heap size. Think of them as setting, for example, the lower and the upper bounds of your memory allocation. If you set them too low, you'll face a frequent garbage collection, which is impacts performance. And if you're setting them too high, you will end up wasting resources. So the goal is to find the sweet spot where the memory is used efficiently without over allocating. This can reduce like the garbage collection activity, lower energy usage, and of course keep your application running smoothly. And here's our this happy kit celebrating because effective GVM tuning reduces those annoying GZ pauses, leading to a better performance in energy efficiency. It's it's really like for me, it's one of those tweaks that makes a big impact, not just on your apps, but on the environment too. And now that we have optimized the GVM, let's see how we can manage Kubernetes resources to extend this efficiency into the cloud environment. So using Kubernetes for memory management. As for to make our application Java application more efficient, more energy and performance efficiency, we have to containerize them into one container. This is in what's a better way to call Kubernetes. Like this is where Kubernetes shine with autoscaling, especially with horizontal pod autoscaler HPA, because HPA dynamically scales up when the numbers of pod scales up number of pods when the traffic spikes, and scale down when there is some quiet periods. In this elasticity helps ensuring that we are not, for example, over provisioning resources and wasting energy during off-peak times. That happens often the time we are not really monitoring our application. So we can think of it as an elastic workforce or workplace, like more workers or pods. Let's call them pods. Are called when it's needed and sent home when things are slowed down, ensuring that the application runs smoothly. But managing scalability does not stop at adding more pods. We also need to ensure that each pod is using the resource efficiently. And this is where we need to call the vertical pod autoscalers. Like vertical pod autoscalers adjust the resource limit, works to optimize resource usage at the pod level. Because as I said, it adjusts the CPU and memory allocation to individual pods, ensuring each one has just the right amount of resources. This prevents us from under provisioning, where a pod might struggle with too few resources, and over provisioning when it's consumed more than necessary. So you can think of HPA as increasing the number of workers during high demand, while VPA is just about giving each worker the exact tool that they need to do the job efficiently. HPA adds nodes when needed, while VPA optimizes the resource within the pod itself. And together they create a system that's both scalable and efficient, ensuring that our cloud environment runs smoothly without wasting energy. Also, here is some simple rule you can use or to keep in mind. Reduce, reuse, recycle your container. By optimizing resource within each pod, we are reducing waste, reusing resources efficiently, and ensuring that every container plays its part in minimizing our environmental footprint. And finally, let's talk about how to define resource limits and requests. For our part, make sure that we are allocating resource effectively without risking of the over provisioning, because we need to know why resource limits are met. For example, requests set the minimum resource for each pod needs will limit cap, for example, the maximum they can use. It's like giving each worker enough tool to do their job well, but making sure that no one takes, for example, more than their fair share. So by defining this parameter properly, we can prevent what we call the resource hogging, where one pod consumes more than it needs, potentially causing issues for others. So to recap, by using the auto-scaling, resource allocation strategies, and proper resource limits, we can create or we create a Kubernetes environment that's both efficient and eco-friendly. So every optimization makes from code to the cloud contribute to more sustainable technology landscape. And now, Java and Kubernetes, the perfect duo. Like by combining the flexibility of Java with the scalability and the management of Kubernetes, containerizing Java apps allowing you just to pack everything from code, dependency, library into a single container that can run anywhere. This makes Java apps more portable and adaptable. And with Kubernetes, you have an automated system that handles the deployment, scaling, and the management of all these containerized applications. When traffic increases, Kubernetes spins up more containers, and when it decreases, it scales back down, ensuring all about efficient resource use. But sometimes simple deploying Java apps is not enough. And to maximize efficiency, we need to monitor our application in real time, in which is where tools like Prometheus and Grafana come in. Like we need an extra help because Prometheus not only, for example, we not only need to make sure that our Java applications are optimized and that our resources are already, you can say, efficient, but we need to make sure that this is happen in real time. This is why we need some monitoring tools such as Prometheus that collects detailed metrics from application, including GBI metrics, such as the memory usage, CPU consumption. You can take all these metrics and visualize them to customize dashboard because sometimes you cannot really just read all these logs. We need to make them in more fun way. So you can also make sure you keep updated about what's happening in your application in a more fun way, or we can say colorful way. So, for instance, if you notice a spike in CPU usage or memory leak, you can adjust your application configuration immediately. And that's help preventing resource wastage, improving performance, and of course, ultimately reducing costs. And this is one of the benefits of optimizing resource usage because it's not only help the environment, lowering the environmental impact, but also lower the cost, the financial one. So also while Promothought and Grafana are powerful, the CNCF ecosystem offers many other tools and projects that can help you optimize your Java apps in Kubernetes. And one of my favorite one that I can say I read about them and I hadn't chance to use them all, but there are really some good feedback about them. And my favorite one is the keep state metrics, which is a tool that provides detailed metrics on the state of Kubernetes objects like nodes, pods, and deployments. It's a great way to keep track of cluster health. There is the GR help you monitor requests across in services and microservices. This is particularly useful. Why? Because It helps you identify bottlenecks in complex multi-services applications. And of course, there is the famous SCADA, which is a Kubernetes event-driven autoscaling that allows you to autoscale application based on the custom metrics. So, sorry, such as mm, sorry, such as the messages in the queue or even external metrics like web traffic tool. It's a good tool. And there is the Fluented, which is an open source log aggregator that helps you collect, parse, and route logs data from your application. This ensures that you always have insights into what's happening under the hood of your apps. So these tools, alongside with Promothought and Grafana, give you a full suite for monitoring, scaling, and managing your Java apps in Kubernetes in a more efficient way. So you have the tools, and now you can truly build an efficient and eco-friendly Java apps that scales seamlessly in the cloud. Green Java development projects. Because of the short time, I'll just show you one of my favorite one, like that showcase successful implementation of the green programming techniques and their measurable impacts on the environmental conservation efforts. Ladies and gentlemen, here is the Mozo Bank. The Mozo Bank from the start adopts green programming practices and sustainability into the digital banking. By optimizing their Java microservices, Monzo has significantly improved the efficiency of their software. They also translate to a cloud infrastructure that emphasizes sustainability, leveraging, of course, Kubernetes for efficient container orchestration. And this move, you can say, has reduced idle resource consumption and boost overall efficiency. As a result, Monzo have achieved 35% of reduction in energy consumption and significantly decreased their carbon footprint. And what's really important, more than 500,000 customers are actively engaged in Monzo sustainability initiatives. It's all about fostering a community of environmentally consequences customers. And to wrap up, here are some fun tips to keep our application as green as possible. First thing first, code like a tree with a deep root for strong foundation and efficient branches that keep your code lean and fast. Next, our favorite motto, reduce, reuse, recycle your container, just like you recycle in real life. Recycle your container by optimizing them for minimal resource usage. And remember, every line of code you write is a vote for a greener future. When we write efficient code, we are not just improving performance, but we are also helping the environment. Now, let's make it a fun, quick, interactive challenge. Think about your code space, your project right now. What's the one area you could optimize? Maybe it's an efficient load, a memory leak that you could predict it happen. Got one in mind? Congrats, because you're already one step closer to building a greener cloud. And you can say Java and Kubernetes are really the perfect tool for creating more efficient and eco-friendly apps. If you are using other programming languages, there are always a way to help to get rid of to lower your environmental impacts. Look for it. Look how you can reduce your usage, memory usage, CPU usage. Also, because as we said before, when it comes to the environment, we don't need only to rely on, for example, the data center providers to look for more friendly, environmental friendly resource usage, but we need to start from us. Baby steps are better than zero steps. Start where you code, optimize your containers, because it's only step by step that we can help the environment. So my challenge, the real one to you, is that optimize one of your application or Kubernetes cluster this week. It's always a small step toward building a greener cloud, So who's ready to take the first step? And I would love to hear from you later about your next green steps and their impact. You can reach out to me via Twitter or LinkedIn. So let's make our code cleaner and the planet greener. And thank you all for enjoying this green talk.
Thank you so much, Aisha. It was a great introduction. I don't believe you uh, you had trouble in adapting this talk. It's a very comprehensive overview of what's going on in the field, and I hope to see you more often in the activity of the tag. So, all right.
And
Again, if you have any questions, we do have a couple of questions. Unfortunately, I think we are. I don't want to, accumulate too much delay.
and
But yeah, so
I try to make it
I
quick, just
people will
in
be able
case they
to.
have.
I guess people will be able to ask you questions directly, or even better, if this question go in the Slack channel, which we're gonna post soon, the link, then would be great because then everybody can see and can interact. All right. So next in line, of course, we have who do you have? Davide Bianchi. Thank you, Davide. If you are online. You would,
Yeah,
yes, David.
I'm
Thank you
here.
so much because you jump in very last minute.
Yeah.
You just had yesterday the very first, I think, event in Milan for the Sustainability Week. So, how did it go? How was it?
Great, but I can't go to the event, uh, mm, so it's but some other attendees say me that it was great. So yeah.
Okay, okay, good to hear. Good to hear. So, you're gonna talk about the amazing project, Kube Green. So take it away,
Yeah.
and if you can share your screen, uh, we,
Yes. Sure.
you're good to go.
Okay. Okay. Do you see my screen?
We
Yeah,
do.
yeah, it's visible. Yeah. Thank
Okay.
you.
Perfect. Thank you. So I will talk about sustainability and efficiency, environmentally friendly software development with Kube Green. Okay, first of all, a presentation of myself. I'm Davide Bianchi, product engineering manager working at Mia Platform. In this talk, I will present an intro to sustainability. This I will talk about sustainability in the IT sector. I will talk about the green software, Kube Green, and I will talk a little bit about some tools and some conclusion about the usage of those tools and the green software itself. Okay, short introduction to sustainability. Sustainability is not only about environment, is also a set of the economic, social, and environmental factor. So all of these is set the sustainability. In the IT sector, we will talk about principally in this presentation about the environmental sustainability. And the ET resources consumption are due by the computation, so the CPU, the usage of CPU and GPU, the usage of the storage, the networking, manufacturing of a server, and transporting of this server to the data center, and the cooling equipment once the server are running to maintain refrigerator them. Okay, this is where the IT consumes a lot of energy. And it's important always to remember that the whole we do online run on a server somewhere. So the cloud is running somewhere, and also the code we write on a server consumes energy and produces carbon. Let's say some example are really interesting from my point of view. Example is the environmental impact of an email. Sending an email without an attachment has a carbon footprint of 4 grams of carbon equivalent. And if we had an attachment, it reached 19 grams of carbon equivalent. And if we say that in one day, the average per user mail sent or received are around 100, we have that in 1 year there is an average of 150 kilos of carbon equivalent produced only sending emails, which is more or less equivalent of driving a mid-sized car for 1,000 kilometers. Okay, but more in a huge size. If we see the heating global electricity demand in 2022, we have that it's around 460 terawatt hour per year. So more or less 2% of the global final electricity demand, which is in 2020 around 330 million tons of carbon produced in the atmosphere. This number now will increase because there is the artificial intelligence, there is the cryptocurrency, and there is an addition of the usage of the consumption of the resources. And we have from a report of the International Energy Association, a report which say that in 2026 we have around 650 to 1050 terawatt hour consumed in 1 year for the ET energy, for the ET industry. So it's equivalent to the energy demand of Sweden or Germany, respectively. So a really huge consumption of energy. But how can we avoid to consume energy? There are, for sure, a solution, which is avoid to use software and to use cryptocurrency or artificial intelligence and so on. But it's not feasible. Like, it's our work, and for sure, some technology are really useful, are really interesting. So how can we create more sustainable software? There is a practice in the software practice, which is called the green software. And first of all, is important to say that there are some groups which are talking about the green software and are talking about the environmental sustainability inside this sector. And two examples are the Green Software Foundation and for sure the CNCF tag on environmental sustainability. And it's really important to advocate for the sustainability and to create initiatives like the Cloud Native Sustainability Week, like this one. Okay, but what is the green software? Green software is carbon efficient software. So software which emits the least carbon possible, and it's based on 3 principles, which are energy efficiency, so consume at least amount of electricity possible. Energy efficiency, for example, we can create software which consumes less possible amount of energy. So we can write efficient code, optimize data handling. We can write in a more performant programming language, use more performant hardware, and so on. Another possibility is the hardware efficiency, another way to improve the green software. So use the least amount of embodied carbon possible, where the embedded carbon or embodied carbon is the amount of carbon pollution emitted during the creation and the disposal of a device. So we can, for example, extend the lifetime of an hardware. So use an hardware instead of, for example, 2 years for 3 years, or increase the device utilization. So instead of have 5 server used only about 20%, to have 1 server used at fully resources. And the last principle is the carbon awareness. So do more when the electricity is clean and less when it's dirty. So make some spatial or temporary shift of our workload. For example, to consume less energy, for example, I don't know, during the day, if it's possible, and to run some workflow only during the night, or to shift spatially, so run our workload in some region which have an amount of green electricity instead of, for example, electricity derived from coal and so on. And we can now make a focus on Kubernetes. And if we take Kubernetes as a technology, we can use the autoscaling and scale the application accordingly to some metrics. One example, so upscale the resources when it's needed and downscale the consumption when it's not more necessary. So, for example, upscale when there is a peak, a surge in the consumption, in the number of users, and when the peak is passed, downscale to reduce the consumption. This has repercussion on the environment and also on the cost of our infrastructure. So it's a win-win. And there are some tools that can help us to improve the scaling. For example, there is Kubegreen, which is a scheduled. KEDA, which is a event-driven auto-scaling, really powerful. And the HPA inside Kubernetes. And there are also some tools which help to measure the electricity consumed by our application, for example, Kepler or Scaphandra, and make some optimization in this way. Or also that some machine learning scaling optimization tool to adjust the configuration of our application to reduce the consumption of our tool and improve of our service and improve the performance of this one. If we have some project in active development, for example, we have probably more than one environment. So we have a production environment once released and some or a lot of non-production environment. For example, the non-production environment of UAT, development, testing, and so on. And if more or less there are 40 hours in a working week, more than 75% of the time in a week, those services are unused, but are still running in our infrastructure. So the usage of Kubernetes is to turn off this development environment during hour like the night and weekend, when the resources are unused. Kubernetes is an open source operator available on GitHub. Here, available on GitHub, which run inside a cluster. And it's possible to configure via CRD called sleep info. In this slide, we can see an example of the sleep info CRD. And it's possible to set up the resources to sleep and wake up when needed. And so it works at scheduled time. At the moment, it only supports deployment and cron jobs. How can we use KubeGreen? We can install in our cluster,
Yeah, come in.
configure the CRD, the sleepinfo CRD in the desired namespace, and see the KubeGreen in action at the scheduled time. And there is, for example, on the KubeGreen website, a really basic tutorial to work inside a kind local environment to test and to try the KubeGreen workload. Okay, there are for KubeGreen new coming feature that are now in the release candidate release. For example, I said that KubeGreen support only deployment and cron job, but this is no more true, because it's now possible to configure also custom resource of any kind, writing some easy patches to turn off, to change the custom resource so that it can turn off a resource. And this is a feature which we are testing in the past few months, and we can release soon. It's already available on GitHub. And there are also some community improvement in KubeGreen. For example, the creation of the Helm chart, native support to the stateful set resources. So there is the stateful set resources added to deployment and as of now, there was only the exclude ref filter. So it was possible to exclude some resources from the sleep of the namespaces. But now it's possible also to include, so to add by name or label the resources to include. So we can see some real-life usage of KubeGreen. We can see a chart. This is the difference on when KubeGreen is installed in a cluster. And we can see on the left of the chart the consumption of memory. And on the right, the consumption of the memory, which take it's more it's scaled. It's really visible the night when there are the night and the weekends in this chart, because there is a reduction interesting of around 20 gigabyte of limit and also of memory request. And so it's possible to see that during the night and the weekend, the workload are turned off. And the same chart is possible to see for the consumption of CPU. And some chart in a cluster with 75 namespace, and 48 of them have KubeGreen enabled. We can see that during the night are turned off 600 pods with a reduction of memory usage of 33 gigabyte and the request, so the byte, and a reduction of CPU usage of 3.5 core, and a reduction of the request of the CPU of 25 core. And once we saw this data, we we are asking why the chart, the cluster nodes does not downscale. And yeah, we have not the downscale enabled on our cluster. We enable the downscale, the node downscale. And this is the chart of this cluster with the node downscale enabled. And we can see that the number of nodes in this cluster passes from 12 during the day to 8 nodes during the night and the weekend. So more or less each night and each weekend, we have 4 nodes turned off, which is a reduction in consumption of energy for sure, and also in cost because yeah, less nodes consumed.
We are
It's a reduction also
doing
for the
this
cost
mini virtual
of
conference.
the usage in a cloud provider. Okay, some number around on KubeGreen. KubeGreen, an interesting number of adopters now use KubeGreen. There is a non-exhaustive list on the website, but there are also a lot of users which use the KubeGreen but are not listed. And we have more than 650,000 downloads of the KubeGreen image during the time, which increase month by month the downloads. And talking with the users which already use KubeGreen, for example, you have an average of 30% of the reduction in cloud cost with a consequent reduction in emissions. So to conclude, some key takeaway. So sustainability is important also in the IT sector, and it will be always more important. And it's important to think about it in the software life cycle. There are some groups which can help you to create green software. For example, the CNCF tag on the sustainability. The environmental sustainable transition could start thinking about the cost savings, which is the first milestone, but once reached, it's important to go on. And in Kubernetes environment, it's possible to improve the energetic efficiency using tools like KubeGreen. So thank you. I hope you enjoyed it. And yeah, if you like the project, star the repo on GitHub.
Thank you, Davide. It's a great project. It's been around for a while, and I remember it. And it's impressive how brutal can it be when to switch off pods. So I'll be a bit scared to run in my clusters, but no, maybe I should I should take the ball and just do it. Thank you so much. Again, we don't have a lot of time left for questions, but we do have a channel which I'm gonna pass the link now in the chat, both on YouTube and here on Zoom. And without further ado, we will continue with the lightning talks, right? So this is a time where we assign 5 minutes each. So there were because we wanted to get more and more speakers. So if we can go ahead, and David is online. David from Leaf Cloud. Hey,
Yeah,
David,
I am.
how you doing?
I am. How are you guys?
Perfect. You sharing your screen?
I will. I cannot share while other participants are sharing, so I have to.
I think David is still
Someone has
sharing.
to stop sharing. Yeah.
This is David's screen, I suppose. Ah, yes.
Yes.
Yeah.
Perfect. 5 minutes.
Yeah.
Cutting through the noise. So please
Yeah.
give it a go.
Just a quick one. Basically, in really short, I used to be a bicycle mechanic when I was in uni, and after some years doing that, I realized that the people who know the most about bikes tend to spend the least on it. So I think there's a bit of a parallel to that. If you know a lot of IT sustainability, you can emit the least. I think I'll go into that a little bit. This is sort of the image that the general cloud providers want you to see of their cloud, right? They use green energy, they cool their data centers the most efficient way possible. They offset whatever is left, and they put data centers where green energy is available. This is the picture you find on Google's sustainability page. This is Google Eemshaven in the Netherlands. This is sort of their perspective of it, right? This is my perspective of this. Just slightly pivot the camera, and you see this. A real massive coal-fired power plant right next to the data center, and some windmills for the image. And that's the reality of it, I think, in a lot of ways. The entire subject of heat reuse is not used on Gugamasoft's corporate sustainability pages. PUE1, the most efficient data center in the world, means you threw all the heat away from those servers. It doesn't mean that you've cooled efficiently, or sort of does, but it also means you threw away heat efficiently. Of course, we've touched this subject before here today, but AI will massively accelerate the growth and energy needed for compute. If you just look at Jevons paradox and us figuring out the most efficient way to ask a computer a question, this is just written in the books. And because of that, data center costs are out of control. And then, again, you don't have to believe me here. Microsoft footprint growing 21% in 22 and 30% in 23. In Ireland, 21% of all electricity going to data centers. That is insane, and we have to curb this. Now, I think one of the things that is massively misunderstood in the software field is how efficient is a computer? Now, when I ask software engineers the question, when you look at this picture here, right? How much of the energy that you put into a server actually becomes useful workout, and how much becomes heat? The general answer tends to be like 60%. But the reality is that information is not a form of energy. So it's a trick question. All of it becomes heat. All the energy that you give to a server becomes heat that comes out of it. And the information is just a useful byproduct of it. It's not a form of information. So about one core VM for 1 month is about the equivalent of one shower. That's an easy way to sort of get there. If you'd say you put all Dutch data centers, take all their electricity and turn that into hot tap water, you do about 50% of all the warm tap water needs in the Netherlands. So there is a massive use case for that waste heat that isn't being utilized. And sadly, we can't offset all of it. University of California doesn't think so. And they have made a really, really good paper on it. Why offsets are, or at least paying for offset isn't that useful. You should probably focus on reducing the emissions of your own company or corporation, your own buildings. That's the more important part of it. So why does it matter? Let's say we have a 10 kilowatt workload, about 2,500 cores or 8 to 16 GPUs, and you run that for a month. That's about 6,000 showers of carbon equivalent in a gray data center. Now, if you make that workload slightly more efficient, and I'm not trying to bash the rest of us here, but this is what most of the software engineering field in terms of sustainability tends to focus on, is this making the workloads more efficient. That still doesn't count for that much. Now, if you move that workload to where you have actually green energy, Scotland or Norway, you make a massive impact, right? However, the reality, what we see in Ireland, we can't move all the workloads there. It would simply not be, there would not be enough energy there. There would not be enough space for all the data centers there. So this is not a realistic option for all of us. It might be for some for some massive workloads, and it will be very effective to do so. But if you move that workload where natural gas or other forms of fossil fuels are used to create heat for showers, for tap water, for heating in other ways, you actually reduce carbon for our total society as a whole on a large scale. So it's minus 1.3 tons. Now, what we did is we basically did this right in very short. We put servers where heat is needed in leaf sites. So those are apartment complexes, swimming pools, elderly homes. We make a distributed data center out of that. That is just as secure, just as up as what the big guys are doing, but much, much more sustainable because we actually use the heat. And I don't say reuse because it hasn't been used the first time. That's my lightning talk.
And we love it too, of course. But unfortunately, there are no questions. But it is a great talk. I think I saw it before, but it's always
Yes.
fresh. And thank you so much. Yeah, I encourage everybody to come over to Slack and ask questions there. Most of the speakers are already in the cloud native Slack, and I'm sure there will be a lot of interesting discussions to be had. And don't forget, we do have regular meetings. Yeah, I'll send a link now. So thank you for submitting, and great to have some more hype words in the program. Thank you. So if you guys are okay, you can share your screen and take it from here.
Is my screen visible?
Yeah, it's visible.
Yes.
Yeah, so yeah, I'm Rohit, and I will be talking about sustainability today with Shivai. So we are talking about WASM WebAssembly, which is like driving faster, greener computing. And we will explore how WASM not only enhances performance, but contributes to your sustainable software development practices. So yeah, so the urgent sorry, sorry for the slides change. So the urgency of a sustainable computing. As the world confronts the urgent challenges of climate change, the software industry has a key role to play, right? So data centers, which are the backbone for our digital world, currently account for 2.5 to 2.7% of global emissions, and this is expected to rise to 14% by 2040, more than the aviation of industry, right? So moreover, the software industry's emissions at around 4 to 5%, already exceeding the aviation's like from 2.8%. And this addressing this carbon footprint is no longer optional. It is critical for us, right? So that's why we present WASM. So what is WASM actually? Like if you saw previous officers about WASM, or like Shivai and me talking about WASM and stuff. So WebAssembly offers an opportunity to tackle this challenge head on. Like WASM is an universal bytecode format, meaning it can run on any platform, whether in the browser, cloud, or at the edge, whatever you want. It delivers near native performance, which is like lightweight and operates in a secure sandbox environment. Importantly, WASM supports over 20 programming languages, making it highly versatile for developers. Yeah, so how it is different from containers. So let's take a quick look. So WASM compares to traditional containers. Containers, while useful, come with certain limitations. They are bigger, with slower startup times, as they require launching an entire OS environment. They also consume more memory and CPU sources and are tied to OS-specific dependencies. Even though they are portable, and you must have come across the Docker, which is like commonly used container, right? It's directly on the host system with minimal overhead. It's more efficient, consuming fewer resources and platform agnostic, meaning it can run in any environment, which we discussed, without relying on any OS-specific dependencies. This efficiency in resource utilization makes WASM a natural fit for sustainable computing. So further, WASM's ability to drive sustainability doesn't end with general computing. It also extends to AI inferencing. WASM allows for quick model spin up and shut down, making it highly efficient for AI workflows. Furthermore, WASM offers efficient GPU management and cross-platform compatibility from development to production, ensuring that you can maximize performance while minimize energy usage. This enables AI to be deployed with a smaller environmental footprint. So without further ado, I would like to Shiva to come on the stage and continue this talk. Thank you.
Yeah, thank you so much. So, as we know that with respect to AI inferencing, a lot of today is happening with the help of large language models. So that is why, since large language model training actually takes up so much amount of compute and that is contributing so much to the global carbon emissions, you need to find a way to actually be able to do the inference of these models in a very quick fashion. Because let's say if you load a typical PyTorch model inside of a container, it will have a size of at least a few hundred megabytes. Whereas if you can run that same source code in multiple different platforms and in different types of system architectures, edge architectures, and of course, like combining the WASM inference capabilities and more efficient GPU management that's more standard to Kubernetes with things like the dynamic resource allocation, the dynamic scheduling of your GPUs so that you can allocate more accessibility to the GPUs for some of the smaller models. All of those combined can really help make your performance orientation much faster. Now, also let's take a look at one use case example. So this is one of the most famous examples for WASM in production right now with a collaboration between Civo and Fermion. Civo is a provider for Kubernetes, and Fermion is a WebAssembly native platform that has the project called Spin, which allows you to create WebAssembly-based microservices. Together, what they do is that with the help of Fermion, you get Spin project that can actually do the machine learning inference for your logic very quickly on the GPUs that are provided by Civo. And considering that, every single WebAssembly workload that runs, it can basically spin up, execute the task, and close down in a matter of a few milliseconds. That basically means that your GPUs are being used in a lot more efficient way rather than to have to wait for containers to start, boot up, and because of this slow time. So that's like where the small footprint of the WebAssembly modules come to picture. And Deep Green, like what is basically happening, is that all of the heat that's coming up from these GPUs is actually being reused to warm different swimming pools inside of the United Kingdom. So this is a great way to reuse that energy that's being spent by GPUs and reuse it over there. And as I mentioned, that the intelligent scheduling of these GPUs can actually then be used for better energy optimization. And before you getting supported for Kubernetes fairly shortly in the next few months and years. And that would basically mean that now you can really just have WASM use case for more efficient AI processing and LLM inferencing through projects like WASM Edge, Llama Edge, and then of course with WASINN, which is a spec for WebAssembly system interface. And of course, a big statistic over here is that with WASM's eco-friendly benefit, you get up to 60% reduction in a lot of different types of real-world workloads because of course, again, as we reiterate the point that WASM's smaller footprint in terms of the memory it occupies and the faster startup time, which means that you don't have you can run your code more efficiently because of these two reasons. It makes it a lot more faster and efficient to run your workloads when it comes to using WebAssembly. And finally, as we can kind of conclude our talk over here, so as we have kind of covered, WASM is an upcoming system that can really help you to make sustainable compute and especially like sustainable cloud compute because it can run not only the browser, but today you're seeing more use cases for WebAssembly on the serverless and on the cloud side. And considering all of the different benefits that we took a look at, that's like one of the leading factors why it is such a promising aspect especially for the CNCF tag runtime as well for sustainable computing, for sustainable computing. And Rohit, you can probably talk about the challenges.
Hi, I think Rohit, you're muted.
Yeah, you're muted, right?
Yeah.
Sorry for
Just the
that.
button.
So yeah,
Thank you.
challenges developer pursuits for the future and of course for the observability, right? Then so yeah, like standardizing efforts we are providing and they are underway. The lot of teams in the CNCF are coming with new initiatives and sustainability is one of them along with WASM. And together we can solve the sustainability issues. So thank you. We would like to conclude this talk and thanks for having us. I work at Typhoon. As a principal product evangelist, and Shiva is working as a developer advocate at a Scout Space. Yeah, so thank you. Thanks for having us. Thank you.
Fantastic. All right. Good. Did I lost myself? So thank you so much, everybody. Thank you for the three for the lightning talks. We have one more, of course. Wilco. Wilco is ready to go.
Yes.
Yeah,
Yeah, I'm
I
ready to
know that he's
go.
very excited to be here. And of
Yeah.
course, like I know Wilco for some time now. We both live in the Netherlands. We do
Yeah.
run the local meetups, local community around cloud native, and especially now around sustainability. We do have an event this Thursday, and we're all very excited. So Wilco's enthusiasm is contagious, and it does
Thank you. Thank you.
yeah, it does infect me very often. So take it away. Share your screen. Yeah,
Yeah.
you are sharing your screen.
So
Thank you.
5 minutes. So buckle up because I have a lot to tell. And yeah, if you want to watch something back, you can do that later in the YouTube video, of course. So green coding in practice, the CNCF way. Oh, let's see if my... Oh, why is not my keyboard working? Yes, there we are. I'm Wilke Burghaaf, green software champion and architect at High-Tech Innovators. I'm located in the Netherlands, in Europe. Green coding. The code we write impacts the hardware it runs on, whether locally or virtually in the cloud. So a frequently asked question is, what code should I write and which library should I use? But sadly, it's not that simple. So from my perspective, green coding is a continuous improvement loop driven by experience to optimize code, minimize negative impacts, enhance positive outcomes, and adapt to renewable energy sources, or use solutions like Leaf Cloud. And by observing factors like energy use, computing efficiency, hardware temperature, time efficiency, and the value the code creates, you can gain experience. And today, I'm not talking about emissions, water usage, embodied carbon, pollution, and social impact. They all matter, but my initial focus in this talk is on hardware resources consumption only, mainly on the CPU. So in the CNCF ecosystem, we already use observability for decision making. So let's apply it to sustainability too. So suppose we need a code example because that helps to test all the green coding metrics we just discussed. This will allow us to put them to the test. So yeah, you can use Kepler. It's not simple, but we're not going to use it in this talk. So file you can access in the proc with kernel dumps. It does it kind of in the setup we have every 10 milliseconds. And yeah, we can use that eventually on core level to calculate the energy use on a certain model that we're currently creating. And for the example, we use a large loop in a test case API pod operated by Linux. And the main arguments are like dynamic number of iterations, dynamic number of threads. We have a simple operation, just does plus plus, and we measure every 10 to 20 milliseconds. Is this possible? Well, what I'm now showing is mainly an API that we set up. And I don't know if you also see this. Okay, maybe it's now sharing better. So we have an endpoint where you at the API come in, a test use case endpoint. And at one side, asynchronously, we run the big loop. So we run the big loop based on the arguments on the thread count you give up, the amount of iterations that you want to run. And then in this case, use case one, do the plus plus. And also we every thread, so all the work gets divided for all the threads, and then that gets executed. Then at the same time, we do all the measurements. So we every time 10, 20 milliseconds, we do the measurements. We create based on that deltas, and then eventually we organize that later on in blocks of 50 milliseconds. And I will show later why that is. So at the end of the API, it will just give a short summary. But at the same time, we in a state bag, we save that state and make that available for Prometheus, so Prometheus can scrape it. And also in this case, we run Dapper. It was left on the top. And also in the next month, I'm focusing on using Impact Framework so that it's not my code that is calculating these deltas and the 50 millisecond blocks, but it's done with the Impact Framework in a manifest file. So we can do it in a validatable way, and also that it's open for everyone to see how it works. So in this case, I created a front end. And this is what you're looking at. It's a Blazor in a WebAssembly. We just heard that in the last lightning talk. And I made some green and orange and yellow just to have an idea that the amount of threads you choose have a certain impact on the certain metrics I explained earlier. So the computer efficiency, the heat eventually, that kind of stuff. So in this case, in this example, it's running on 30 threads. We're doing 25 billion iterations with just plus, and it consumes in this one request, it consumes a 207 joule. So it now run in 4 seconds. If it was 1 second, it would have used 207 watts, to give you just a roughly idea. So the Prometheus endpoint that I explained shortly earlier, it has like this 50 milliseconds blocks, and you see on the right side, you see the utilization. So 4%, 0%, 26%, 26%. And for each 50 millisecond block, we calculate or estimate the joule used for that block. You see also that measurement isn't perfect. So the 50 milliseconds is based on the starting time, but some durations of measurements take 60 milliseconds, sometimes 20, sometimes 30. It has to do with how it dumped in the proc stat. And first we try to correct it, but we don't do that anymore to keep the energy as correct as possible. So Prometheus is scraping it, it takes it up. We not only using then the endpoint of this API, but we're also scraping the metrics of the traces, so we can connect the code eventually to what happens in the in this case what we give to Prometheus. And then in this dashboard, I try to explain really fastly what's visible here. So we have the total amount of the request on joules that is used for the total request. We have the amount of actual threads used, and maybe in the bottom, what everybody expects is that you see the cores or the threads, but that is not the case. What you're seeing is from the starting point to the end point of the code, every 50 that is with that block, but we're validating that, and I don't want to put something on the internet that hasn't been completely validated yet. But then in that case, you can then trace back. And in this case, it's a loop, of course, right? So it has now all kind of the same utilization. But if we shouldn't use the loop, but just real code, you would have seen with database connection and network connections that it would have drops. And then you can relate it back, hey, this kind of utilization and high doesn't needs to be bad, because sometimes you really want to do something very efficiently in a short time, so a lower amount of bars, or maybe you want to set it more on the lower side. So that is the place where you can make decisions, sustainable decisions. And that is what I'm aiming for. So in the end of this front end, what we can do with this information, we can use that information if you would run this request multiple times, in this case, 882 times. You would run it for an hour, and based on that, you could say, okay, if you run this for an hour, it would be 50 watts, and based on 50 watts with 217 grams of emission in the Netherlands, it would have been 12 grams of emissions for an hour of these requests. So you get a better idea on what's happening. So the goal is to offer this as a foundational starter use case for green coding observability in the CNCF tag environment GitHub repository by the end of the 2024. And I hope that I can make someone enthusiastic at CNCF tag environment to eventually do more with this together. So this is the end of my talk.
Wow.
That was
Okay.
amazing. You covered a lot in 5 minutes.
What did I just watch? This is something I'm gonna watch again a few times. It's amazing. It's so cool. Thank you so much. I hope you plan to present this at KubeCon or the United
Yeah.
Nations. Maybe that's a better place for this, right? So
The
thanks,
next one
Wilco.
is already confirmed on Green AO in Paris, but yes, I want to spread the word on many places as I can, and also bring CNCF and Green Software Foundation as many organizations together, because alone we're not gonna make it.
That's
Indeed.
amazing.
Yeah.
That's a great point of view. Thank you, Wilco.
Thank you, Wilco, and see you soon. So what's up next? Some updates from within the working groups. So we do have the comms working group, and that's Claire and Valeria. Thank you for being here.
Over to you, folks. Yes.
Everyone should be able to see my screen.
Yes,
Okay.
yes.
Amazing. Okay. So we're from the working group communications as part of the tag. I'm going to be doing the first half of this presentation. I'm Claire, and I work as a site reliability engineer at Calusa. Valeria will be taking the second half. So the working group essentially is aiming to help the tag to communicate within the community of the tag itself, but also the wider community outside of the tag. We're trying to make sure that everyone is able to contribute, join in, and learn as much as they can and as inclusively as they can across everything. Sustainability, advocacy, and events and blogs. There are a couple of different roles, and actually some of this is new leadership. I've been doing this for a little while now on my own, and I'm really happy that I now have Nancy as my co-chair, and I also have Valeria as my tech lead. This is amazing, and I think this is going to really help us as we start to plan what we're doing for the rest of the year and the next year. We also have a couple of different sections. So we kind of have the core team and what we do, and then we have subsections as part of this because working group communications and sustainability is quite broad. A lot of that is things like creating events. And, I helped to organize the in-person meetup in Paris, KubeCon. That was really awesome. It's really good to bring everyone together when we can. We also have kind of advocacy and making sure that people are learning about sustainability and driving that forwards. We also help to maintain the website, which is awesome. We also have a blogs lead who makes sure that when we have people that have content that they want to kind of share with the community and outside, we're giving them a platform for that. And that involves kind of editing them and experience, which we're not doing so much with, but everyone in the tag is so lovely that we kind of just make sure that keeps happening. There's definitely a space for anyone that would want to do more with that. We're also working into the roadmaps and more content generation and kind of advocacy stuff generally in the working group. So we want to do a bit more about, actually generating the content and teaching people and bringing in all of those different projects, as you can see in the top right corner, that kind of fall under communications and advocacy and marketing for environmental sustainability. I think this will be a really interesting thing coming for the working group as well. We also have quite a few things that we're actively working on. There are more than just this, but these are the key ones that kind of come up week after week. We're a relatively new working group, and actually all of the leadership is relatively new as well. So we've been working with the leads of the wider technical advisory group from sustainability to define the roles that we have. So those are those kind of sub-lead roles, people like the website leads and people helping with events and really what we're actually trying to achieve, defining those and making sure people know what they're doing. And also ensuring that they know how they can access the different resources that they need. That's something that I've kind of been championing, and I think that's going to really help shape the working group and what we do. We're also really working on a roadmap. So if anybody wants to help out and really make it what it is, that would be great. We have the opportunity. Now is the time. We're redefining what we're doing and how we're doing it. There's going to be a lot more kind of active things that we can do, as well as just keeping everything chugging along. We're also trying to create an event calendar, trying to make sure that everyone knows what's happening throughout the year. And I think just trying to give some sense of when things are getting more busy for us. Obviously, October is an insane month now, with the Sustainability Week becoming kind of Sustainability Month. We also have an ongoing kind of activity, not quite a project, but website translations. We have a bunch of really amazing community members that kind of translate things, making sure that things are inclusive and people can learn in their languages. If people know a language and want to translate and help with that, that's amazing. We also have some automation work with that. So trying to make sure that everything works really effectively. And we know when something changes and we need to automate. We automate when something changes so that we know, hey, a translation needs to happen. And we also have a bunch of different projects, which Valeria will now take us through.
Yep, I will continue. So you already introduced me, so I don't waste much time. The first project we wanted to introduce you is the landscape document, which is on this working group roadmap. What is the landscape document? Is a document that captures the known and ongoing sustainability efforts within the cloud native landscape, as well as identifies challenge areas. There's a lot you can see in the right of the slide, the table of contents. So there's a lot to learn and a lot to write. Is a document that is ongoing. So if you want to contribute, it's a very cool project. Claire, go on with the other project. Yeah, this second project is the user stories project. This one is very personally important. You can find the project proposal on the link on the first element of the slide. What is the user storage project? The user stories project has the goal to collect real-life user stories and use cases related to adoption and implementation of tools and practices for cognitive environmental sustainability. We started this project because we found that we want to learn more about and have more user stories to share. And so we found that the working group comms is the working group perfect for this project. If you have a user story to share, feel free to write a comment in the issue or write a comment on Slack everywhere. The last one, if you're here, you know about Sustainability Week. This project, starting from next year, will be a part of the working group comms. So if you enjoyed this, as Claire was saying before, it's not a sustainability week, but it's becoming more a sustainability month. Let's aim for sustainability year. So we can do a lot of cool things. And last thing is not about projects. It's a very new. Claire mentioned about advocacy starting in the introduction. So we want to tell you that this working group, the working group communications, will be remained to. We needed the effect. It will be renamed to Working Group Sustainability Advocacy. You can find the link to the issue that explains better why we decided to change the name, but to make it short, we found that the term advocacy was becoming better aligned to what we want to do in this working group. So it's not only about communications, it's not only about social media or marketing related things, but it's just more about sharing sustainability things and more about advocacy. Last thing, which is basically one of the most important thing, is how you can find this working group and how you can contribute. The QR code leads to a link tree, if I remember correctly, that leads to the meeting notes and the calendar, so you can add to your calendar and don't miss our meetings. The meeting notes are very important because you can see how the working group can read what we are doing in a more detailed way. And yeah, I think that we can't wait to see you in comms group, which will be advocacy group.
Thank you so much. Thank you, Valeria. Thank you, Claire. I really loved when you mentioned that let's aim for sustainability air. Definitely. Yeah, thank you so much.
And thank
Thanks.
you. I didn't know about the rebrand, so now the cat is out of the bag. It's a great name. So, and yeah, thank you for. I mean, you do a lot, and all these beautiful graphics you
Graphics.
see on the slide deck. That's thanks to this group. So thank you again. One more update from Nikki
Yeah.
about green
All right.
reviews. So what do you do?
So, hi everyone. I'm going to talk a little bit about the Green Reviews Working Group. So what do? We're a long-term technical innovation branch of the sustainability tag. So right now we're focusing on measuring the sustainability footprint of CNCF projects. You can find us on the CNCF Slack channel tag and working group Green Reviews, and we have a repo as well where we keep all of our tooling and infrastructure as code, etc. So who are we? We're a volunteer-run group of open source contributors. So here you can see some of the faces of the working group, but not all. So I'm a co-chair. Antonio is a co-chair as well, and Ross and Flavia are tech leads. How can you join and contribute? So you can join us on Slack. We have meetings twice a month on the second and fourth Wednesday of the month. And you can read about the working group, and the meetings are recorded and uploaded to YouTube. So what is our vision? Our vision is essentially for CNCF projects to be able to request a green review. Part of that involves making it easy to onboard CNCF projects and easily reproduce the benchmark test workflow that we're building. So when we're creating then the benchmark test workflow, we need to be able to configure it and specify a usage scenario. And lastly, we need to have the ability to gather metrics. So sustainability footprint is something we're defining in the process. We're gathering traditional utilization metrics as well as emerging, energy metrics such as through Kepler or Scafandre and more things that I'll talk in a moment. And the idea is to incorporate these sustainability metrics as part of the software, the building software as part of the life cycle. So I wanted to highlight the software carbon intensity score because this is a ISO standard that was released recently that is very important to us. And it's something we're building a reference architecture for, but using cloud native software. So this is all in Kubernetes, how to get energy metrics, tie that with high level carbon emissions, how to incorporate embodied metrics, and how to make this a rate. So function, what all of this costs according to a rate, functional units, and track this per release. So we're a year in, we've produced some of our first sustainability metrics. We have a platform up and running and we're automating the workflow. And after KubeCon NA, we'll be ready to onboard a new project. We work with a lot with proposals, which are similar to the request for comments or Kubernetes enhancement proposal, I think it's called. The acronym is KEP. So you can join us with this, with the implementation or writing proposals. And we're using Equinix, we're using Flux, OpenTofu, Grafana, Prometheus, Kepler, and GitHub Actions currently, and we still need a long-term storage solution and to see how we're going to host that. That's something we're discussing at the moment. Thank you for checking in. We're available on Slack in the repo, and I hope to see you in the meetings.
Thank you, Nikki, and thank you for the great work you do in Green Reviews. Congratulations on the new tech lead, and I hope to see more participation in the working group. So, if we are a bit early, but still, what do you think, Nancy? We should go ahead.
Yes, I think we should go ahead. Super
So,
excited.
yeah, thank you so much for all the speakers so far, and let me introduce Brandon, co-founder of Kubernetes, corporate vice president Microsoft. I know him following for many years now. And thank you so much, Brandon, to gift us with your keynote. We are looking forward to hear what's your story. And yeah, thank you for being here. And you can take it from here if you want to share your screen.
Yeah, thanks. Can you hear me?
Yes, perfect.
Yes. All right, perfect. All right, let me get this going. I don't have to admit I don't use Zoom very often, so it's always an adventure when I do.
Next time we'll do it on Teams.
That's right. That's
Yeah.
right. All right, screen share. This one. All right, I hope it seems that's working, right?
Yeah,
Yes?
this one.
Perfect. All right, cool. And you see the full screen, not my notes, because I have like a dual monitor set up here so I can look at my
Yeah,
notes.
we just see the.
All right, perfect. Perfect. Cool. All right. Well, I'm really I'm pleased to have the opportunity to talk today to everyone. And I think this is going to be it was a fun talk for me to put together. It kind of ties together a bunch of stuff that I've done personally,
10 minutes.
and then leads into a little bit of the stuff that we've done professionally as well. So I think that was nice. Normally, I sort of give a very Azure centric talk, and this talk is a little bit more Brendan centric, which is fun to do. So I guess, like everybody's journey, it all begins with something. And for me, it all began with a pond. And so this is my pond out in my backyard. I've kind of always wanted a pond. A different talk would tell you about how that watering can is a continuous fountain, which is a pretty cool thing to set up. But it is a fountain. It is powered. And as I was doing this, and as I was thinking about having this water feature running all the time, I kind of was like, I don't really love this idea of just kind of pumping water in a circle all the time for I mean, it's for aesthetics, I guess, but for no other useful purpose. And I guess that's kind of a minor thing. I mean, at the end of the day, this is like a 2 amp 12-volt 2 amp pump. It's not really a lot of power. It's not going to change the world. But I think that I just sort of like at a philosophic level, I wasn't in a place where I was okay with just kind of like wasting power to drive this pond. And so I thought, hey, well, solar panels are pretty cheap these days. And so let's go ahead and put some solar panels on the shed that's nearby it. Right. And so I put went up on Amazon, learned a little bit about how to wire up solar electricity, backyard solar electricity, and wired up some backyard solar electricity to drive this pump. But like once I did that, I realized I wasn't really content. I wasn't really content with just having these things there. I wanted to understand how the system was working better. I wanted to have a little bit better knowledge around like, is this the right angle? What is the right angle? You actually see in this picture a 2x4 that I had up on the roof that I was messing around with to sort of figure out what the right angle for these particular solar panels were. And of course, because I'm in Seattle, the correct angle actually changes fairly dramatically across the year as, when we get into the winter and the depths of winter. Well, first of all, the sun doesn't come out in the depths of winter very often. But when it does, it's very low in the horizon. So you need, very high angle on the panels to get an optimal charge. And so I thought, well, okay, like I need to better understand what's going on with these things. And so I plugged a Raspberry Pi. In addition to that pump, I plugged a Raspberry Pi into those solar panels, and still to this day, that Raspberry Pi has, even through the depths of the Seattle winter, managed to be powered off of these solar panels for like the last, I would say, 5 years. Actually, it's not the same Raspberry Pi. Raspberry Pis, unfortunately, don't like being out in a shed for very long periods of time. So I've gone through a few computers along the way, but I created on this Raspberry Pi, obviously with a bunch of containers, some monitoring software, right? And so this is where I think the cloud native part of the journey of, don't try that URL, by the way. It's internal to my house local. You can resolve it, but the IP address won't lead you anywhere. The IP address leads you only somewhere if you're on my home network. And these are obviously some Prometheus metrics that are driving the voltage in the amps. Well, there's a sensor here, a digital to or an analog to digital sensor that is wired up to the Raspberry Pi. That's also wired up to the voltage that's coming off the solar panels, as well as the amps. Well, it's wired up to what's called a Hall effect sensor that detects the amps and then turns that into voltage. So these are basically telling me both what's the voltage level of my batteries currently, as well as how much power is coming in from the solar panels into the batteries. And of course, like just having these numbers with Prometheus metrics isn't actually super exciting, but this is sort of the first taste of cloud native technology coming into understanding the power generation of my little endeavor here. But it's also a lot more interesting if you go to visualize it. And fortunately, the CNCF stack and cloud native tech, this is very easy to do, to take these Prometheus metrics, get them into a Prometheus server that's also running on a Kubernetes cluster inside of my house. And then, of course, use Grafana to turn it into visualization. And so I took this snapshot about a week ago when I was putting the talk together. But this is a snapshot of the voltage of my batteries over the course of the last couple of days before I took this snapshot. And you can see, as the sun comes up in the middle of the day, they drive themselves up to about 14 volts, which means it's as charged as it's going to get. The voltage regulator kicks in at that point and doesn't allow the voltage to drive much higher. And then overnight, obviously, it comes down, and that is the sort of the cycle that happens day after day. If it were a cloudy day in the middle of December, we struggle a little bit to get peaked out. But it's very interesting because it actually can help me then tune to understand what's going on. And actually what's especially interesting is there's other monitoring that's out there from the University of Washington with a much cleaner setup. I have a lot of trees in my yard with a much cleaner setup that'll tell you exactly how much solar radiation is coming down every day. And I can actually go through with these graphs and match up and determine the efficiency of the current positioning of the panels for my little setup. And that's been really an interesting learning opportunity, actually, powered by understanding, having the data from easily accessible through Prometheus and Grafana to understand exactly what's going on. So that's sort of maybe the first introduction and the first understanding of how cloud native tech enables us, even locally, me personally, locally, to start thinking about sustainability and thinking about understanding, what does it actually take to generate power in a clean way, in a way that isn't going to impact the carbon footprint and allow me to enjoy my little pump in my pond without feeling like I'm kind of uselessly burning a bunch of power for no good reason. But speaking of burning, somewhere along the line of the lifespan of this, something else happened. Well, it had happened in the past as well, but in Seattle at least, and I think in California as well, and in a variety of other places, wood smoke from wildfires became very, very impactful. Right? We're fortunate we came through this past summer pretty clean. Not everywhere in the Northwest was quite as clean as Seattle was, but we've had significant smoke problems due to wildfires caused by climate change in a variety of areas in the western part of the United States and actually in a lot of other places as well. And this sort of led to the second part of my cloud native journey, which is just like anybody else, I think, who's been through this. You start doom scrolling purple air and looking at the air quality, but then pretty soon I was like, I actually want to understand this for myself, right? Which led me to purchase more hardware. Someone joked with me at one point that whenever a package comes from me, they know that it's probably random electronics, and that's fairly accurate. But this is a light scatter air sensor. If you cracked open an air sensor that you purchased pretty much anywhere, it'd have something like this, probably one of these or something very similar inside of it. It uses it shines a laser beam and detects how scattered the light goes, and then uses that to try and estimate how many particles are in the air. And in particular, it tries to estimate how many PM 2.5 particles are in the air, which is the really small ones that are particularly bad for you. And of course, because I already had this whole setup with the Prometheus monitoring, and I had this shed that was on the solar panels and a Raspberry Pi with a bunch of containers on it, I could actually then just say, okay, I'm going to plug this thing in. It talks over the serial port. And now I can actually expose some Prometheus metrics that show me the air quality. And of course, I can take those metrics, kick them into the Prometheus time series server, and visualize them in Grafana. And so this, again, is a snapshot of the air quality around my house over 4 days previous. This is actually pretty good air quality. It does kind of go up and down, and you could be like, oh my God, it's high peaks at certain time, but actually that's still pretty good. When in the middle of a wildfire impacted time, that graph on the left, the y-axis goes up to 300, let's say. So this is actually pretty good air quality. But what's interesting is it actually led me to some insights, right? Like, concrete example, I don't have the graph, unfortunately, but you can actually see the 4th of July on these graphs. And you might say, well, why do you see the 4th of July? Well, you can see the 4th of July because everybody shoots off a whole bunch of fireworks, and all of those fireworks create a whole bunch of smoke. And it's kind of striking to be like, wow, I can actually see the equivalent of, a giant forest fire in Eastern Washington's impact on the Seattle area from the fireworks that people are setting off. And so, again, through relatively straightforward application of some cloud native tech for monitoring and some cloud native tech for visualization, I'm able to have but also actually I can pick up my barbecue on this thing. So I had a really large spike at one point that I was looking through, and I was thinking through, and I was like, what in the world happened at 6 p.m. And I was like, oh, I was cooking hamburgers. And that's a little striking as well, I think. And it does, again, reminds you, not to say that we shouldn't be doing all of these things, but it's a good reminder and piece of awareness of the fact that we sometimes think, and obviously there are these big global challenges like wildfires going everywhere, but it's both global and local decisions that contribute to all of these sorts of things. And I thought it was pretty cool to be able to understand that. That leads me to a little bit more understanding that I was thinking of, which is outside of my shed, underneath my desk, actually right here, I have a Kubernetes cluster. And I was thinking, and all of the Grafana visualizations and all that sort of stuff are running on this Kubernetes cluster that I've built out of a bunch of Intel NUCs, the next unit of compute. And it just sort of takes care of a bunch of stuff for my house. But I was thinking, and I was kind of curious because I've sort of accumulated this hardware over the years, and I started thinking about, well, I'd really like to kind of understand better, what is this hardware doing, and what is sort of the power consumption of this hardware at various times, and are there more efficient things that I could be doing? Which led me to purchase a smart strip, right? And so this is actually a different smart strip than the one that I used, because this is the picture that I could find. But I took my Kubernetes cluster and I took each of the nodes that are in it, and I attached the power plug to a smart power strip, which actually measures a bunch of different things for that. But in particular, it measures the wattage that each of those ports is using. I had to actually write some code to create Prometheus metrics from this. So there's some client code that knows how to talk to the device and get the milliwatts out of the device, but it doesn't export Prometheus metrics. So if anybody wants to do this themselves, there's a GitHub repo up there that enables you to take one of these smart strips and expose the data as Prometheus metrics. And of course, just exposing points in time as Prometheus metrics is nice because it gives you a certain sense for what kind of power is being used by this particular set of computers that make up the cluster. But it's a lot more interesting if you use Grafana to visualize it. And so that's what you see here. This is over a span over about 6 hours of the wattage used by the cluster. There's a bunch of different things running on this cluster, including the Grafana visualization itself, including Prometheus. But what you see actually in this graph is that most of the machines are mostly idle, right? And actually you can see if you sort of average out, the different machines actually have different sort of steady state wattage usage. And that was interesting from a starting point, because they're different generations of machines. It was interesting to see, sort of what the resting point was. And then also interesting, I saw this spike. There was this very regular spike of wattage, and I didn't know what it was. And then I figured out, actually, I have this. I have a wildlife camera for that pond, actually, because the raccoons love to come and play around in it. So it's fun to get video of them. And every 3 hours, a job comes along and takes all of the camera shots. It shoots a picture every second, and takes all of those individual shots and uses FFmpeg to encode them into videos. And so that wattage spike that you see there, that's the video encoding. And so it was interesting to understand, like, oh, okay, like this is it was a really graphical illustration of the fact that these processors they do have different amounts of power consumption depending on how active they are. But B, also that this thing that I'm doing, which is encoding these movies so that I can potentially take a look at them, does have this power usage that it puts into the cluster. And it also led me to believe that I think I could actually reduce the size of this cluster, right? Like I could actually get more out of this cluster for less watts by reducing the total number of nodes. And so I actually took it down even further on most of the time to better sort of pack things together. So that was interesting to learn. So I think that's the end of the local part. But this discussion of power, I think, is a relevant bridge to the next thing that I want to talk about. We're fortunate here in the Northwest in that most of the power that's powering all of these things comes from relatively clean energy sources. And, I don't know how you necessarily feel about hydropower, but it's certainly cleaner than coal. And most of the energy that we use in the Northwest of the United States comes from hydropower and a little bit from solar and wind farms. And so, I'm sort of fortunate in that I actually have the option of with my local power utility saying, I just want 100% of my energy to come from renewable sources. But not everybody does, and not everybody has jobs that they want to run in a particular geography, right? When you're thinking about running data jobs and you're thinking about doing AI inference and a variety of other things, those things need to happen around the world. And the nice thing about the around the world part is that the global nature of the cloud means that you can actually do things in particular regions and take advantage of the flexibility that you might have in your jobs in order to, for example, go to places where there's excess energy because of solar energy in its daytime, as an example, right? So, some of the challenges of some renewable energy sources is that there's variability in the power, right? There's variability both in the consumption side, but also in the production side. And at different times, the energy mix in different areas is going to be, the carbon footprint of the energy mix in different areas is going to vary. And so if you said, hey, you know what, I have a job that's flexible. It can run sometime in the next 12 hours, but I want to run it in the place where we have the lowest carbon footprint. That's now something that you can do using Kubernetes and the Kubernetes event-driven autoscaler. So Kata is a CNCF project for autoscaling. And we in Azure created a Kata operator that knows how to do carbon aware scheduling. It gets carbon intensity from some data sources that are out there, puts it into a config map, and then the carbon-aware CADA operator actually takes on responsibility for setting scaling limits and scaling inputs to try and scale your job such that you're minimizing the carbon footprint of the jobs that you're trying to get done. And so this has the nice benefit of allowing you to sort of have batch workloads that are running, but that are scaling themselves to try and optimize and reduce the carbon footprint for you. And I'll have a link at the end if people are aware or people are interested in learning more or taking advantage of this. It's built into the Azure Kubernetes service, but it's also available to anyone, anywhere to run on any Kubernetes cluster. And the electrical carbon intensity data is actually global as well, and so you can use different data sources to get access to that. All right, so that's pretty cool, I think, and hopefully that sort of gives you an illustration both of how I think from a local perspective we can use this technology to better understand our own local environments and to build solutions that are at least fun and insightful and hopefully at least a little bit useful for our own local environment. And then as well as the fact that we can also take advantage of the cloud to build global solutions that really help us meet our sustainability goals as a company or as an organization. And I think that this flexibility, this idea that your workloads can move around and can be scaled differently, is kind of at the fundamental of why sustainability is cloud native, right? I think by putting things into containers and modularizing things, we've created a situation in which you can drive efficiency. And you can drive efficiency for cost reduction, or you can drive efficiency for carbon reduction, or you can drive efficiency for both. And I think both of those things are really virtuous, right? I think the great thing about what we've created in the cloud native ecosystem is the tools that both allow you to understand, as we've seen, how things are working, but also that provide you with enough flexibility that you can bin pack to reduce the costs and reduce the power. And you can move jobs around in both time and space to reduce the carbon intensity of the energy that you're using to satisfy those jobs. And so I think that even from the roots of cloud native, where people said, hey, we want modularity, hey, we're motivated by efficiency, those are inherently sustainable goals. And it's nice that we can then marry them up with true sustainability goals around things like carbon footprint. And then finally, I think one of the things that I have always felt really strongly about our cloud native community is that it really is something, one of the things that I'm most proud about what we've built in the cloud native community is that sense of community, is that sense of coming together. And through tools like CADA and many others, I think that we are coming together as a cloud native community to address sustainability, even as we see the challenges of ever increasing power demands for a wide variety of applications. And so I'm confident that as a broad community, we're going to come together and build great technology to solve these problems. I've got some URLs for people to learn more. So the first one is, if you want to measure the power of your own local Kubernetes cluster or anything else for that matter, the carbon-aware CADA scheduler, and then also if you're interested in your own air quality monitoring, that's something that at least when it's smoky around, I'm always really curious about. And with that, I'll hand off to any questions that anybody might have, and I will stop my screen share.
I have a question. I'm very curious if you could share the hardware details that you used, all these sensors and stuff, because I'm really interested in that part.
Yeah, sure. So it's mostly powered with Raspberry Pi that I mentioned. And there's two main sensors. One is I have an I2C. I don't know how much people are familiar, but there's a protocol called I2C. I have an I2C digital to analog converter
Cool.
that you can talk to, and then that's wired into both the voltage sensors and the current sensors. So there's a whole little like breadboard of circuitry that it actually just uses a very simple voltage divider to do the voltage, and then it has a Hall effect current sensor that
What
does
is
the
the?
current sensing.
I'm not an electrician, but what is the smallest measurements you can do with that?
With the current, or like the current sensing,
Yes.
the
Yeah.
current senses down to about I mean, in theory, it gives values down to the 100 milliamps kind of range. I don't know how accurate that is, but certainly, certainly sub-amp range.
Okay, cool.
And up to about 30 amps.
Okay.
I've never seen it drive higher than 10 personally, just because of my own little setup. And then the air quality sensors talk over the serial port. And so you just wire them up to you just can wire them up to a serial port on the Raspberry Pi, and read the data off. They basically just like stream data over the serial port. There's not even a protocol, really. Like it just like pumps. they just like pump data. I mean, there's a protocol in the sense of like there's a byte format, but like it just pumps data from the minute it powers on. It just pumps data over the serial port.
Yeah, now I know what to do this winter. Thanks.
Yeah, for sure. And to be honest, I want to say, like, I leaned on a whole bunch of other people who'd written a bunch of other code for interfacing with these systems, right? So I did a lot of work to interface them, but like most of the code that I used was other stuff that's up on GitHub. So yeah. I used Arduino for a while, but I found Arduino a little. I mean, I like Arduino, but it's annoying when you want to do this kind of cloud native stuff because it's harder.
It's limited.
Yeah, it's harder to administer. You can't really use container. Like pushing out new versions of the software is annoying, especially when it's in your shed and it's raining and you don't want to go outside. And it comes and goes. It's good right now. Winter is good. Winter is good. It's good right now. Yep.
Yeah, I just want to say thank you so much, everyone, for your time. Thank you, Brendan. I also want to mention especially to David because we didn't had a speaker and he came very last moment and helped us and gave a wonderful talk. So thank you so much. Thank you, everyone. Thank you, all the speakers, and especially thank you, the whole tag. There's a lot of hard work which goes behind this and the whole CNCF tag environment week. And if you have anything to contribute, just let us know. We are there in the Slack group. So yeah, thank you. Thank you so much, everyone. Thank you. Thank you so much, everyone.
Thank you. Bye.
Bye-bye.